In 10.6a, we're learning about Pascal's triangle and the binomial theorem. So first I'm going to show you how to make Pascal's triangle. So if you look at all the rows, one thing you'll notice is that the beginning of every row is 1 and the last number in every row is 1. So the way you get the other numbers is you look above. So you see a 1 and a 5, add those together and you get 6. 5 and 10, add those together, you get 15. 10 plus 10 makes 20. And then 10 plus 5 again makes 15. And 5 plus 1 makes 6. So if you look at any other number, like take this 3 for example, that 3 came from 2 plus 1. So that's how you make Pascal's triangle. And another thing you should know is the first row of Pascal's triangle, we consider that row 0. And then from there, you count down. So that's row 1, and so on. So we just found row 6. Notice row 6 starts with 1, 6. Row 5 starts with 1, 5. Row 4 starts with 1, 4. So whatever row you want, the second number should be the same as the number of the row. And another thing you should notice is every row is symmetrical. So if you look at the last row we made, it started with 1, 6, 15, and it ended with 15, 6, 1. Okay, so for number 1, actually for number 2, we're going to use row 2 of Pascal's triangle because the exponent is 2. So Pascal's triangle is for expanding binomials. So we have a binomial, a plus b. It's a binomial because there's 2 terms, and it's raised to the second power. So we're going to use row 2. Row 2 is 1, 2, 1. So those are the numbers we're going to use. So this is a shortcut to expanding the binomial. So you start with a 1. Then you're going to take 2 A's and 0 B's. Alright, so we've already used the 1, now we're going to use the 2. Okay, after A squared, the A is going to go down by 1, and the B is going to go up by 1. The exponents, that is. Alright, now we just used the 2, and so now we're going to use the 1 from Pascal's triangle. So we have 1, and the A keeps dropping by 1, so now it's going to be A to the 0. The B is going up by 1, so it's going to be B squared. And now let's just simplify. We don't need the 1 in front, so it's just A squared, and B to the 0 is 1. A squared plus 2AB plus 1 times 1 again times B squared. Okay, so for number 3, we're going to use row 3 of Pascal's triangle, which is this one, 1, 3, 3, 1. So we start out with 1, and we're going to do a to the third because the exponent is 3. 1, a to the third, b to the 0. Plus, so I use the 1, now I'm going to use the 3. 3, the a drops by 1, the b goes up by 1. So I use the 3, now I'm going to use the second 3. 3, a goes down by 1, b goes up by 1. Now we just have one more 1 to use. 1, Now we're left with 0 a's and b to the third. So simplifying, we get a cubed plus 3a squared b plus 3ab squared plus b to the third. So this is a shortcut so that you don't have to FOIL over and over and over. It's actually not called foiling anymore because it'll get to a point where there will be more than 2 terms. Alright, so for this next one we want to use 14641. 14641. So we start with 1. I'm not even going to write the 1. 1, a to the 4th, b to the 0. I'm not going to write b to the 0. Plus, now we're going to use the 4. 4, the a's go down by 1. The b goes up by 1. And I probably shouldn't even write the 1. Plus, and now we're using the 6. 6 a squared b squared. Notice that the total for every, if you total the exponents in every term, it always equals the exponent from the problem. So we had a to the 4th, the only exponent was 4. Then we had a cubed b to the 1st, the 2 exponents add up to 4. A squared b squared, the 2 exponents add up to 4. And now it's going to happen again. 4. We only want 1 a and 3 b's, so the exponents add up to 4. On the previous problem, the exponents always added up to 3. And on the problem before that, the exponents always added up to 2. Okay, and the last coefficient we want is 1. We don't want any a's, and we want b to the 4th. So the exponent for a starts with the exponent in the problem, and then the exponent for a goes down by 1 each step. The exponent for b starts with 0, and it goes up by 1. Okay, so some properties. Some of these we already talked about. So if you look at number 4, the exponent was 4, and our final answer had 5 terms. If you look at number 3, the exponent was 3, and our final answer had 4 terms. And so you'll notice that the number of terms is always 1 more than the exponent. So there will always be n plus 1 terms. Okay. How did we get the exponent for a? The exponent for a was always the exponent in the problem. So n is the exponent of a in the first term, and it's the exponent for b in the last term. In successive terms. So as you go on, the exponent of a goes down by 1. So you could say decreases by 1, while the exponent for b increases by 1. The sum of the exponent in each term is n. We talked about that earlier. When we were making Pascal's triangle, we also noticed that the coefficients were symmetric. So row 5 was 1, 5, 10, and then it ended with 10, 5, 1. So the last row we found on the front for the warm-up was, it was actually the 6th row if we consider the first row, row 0. So when we found row 6, it started with a 1, 6. And so the way the numbers are found is actually you just take the exponent, which is n, and you start with nc0. So the coefficient for the first term will be nc0. Well, anything c0 is always 1. So this is how you get Pascal's triangle without doing every single row. So if you want to jump straight to row 10, you can use this strategy. So we're going to find row 6 again without doing Pascal's triangle. So for row 6, the exponent is 6. So we're going to do 6c0. 6c0 is 1. Okay. So now we're going to do 6c1. If you have 6 options and you have to choose one, then there are 6 ways you can do that. Let's find 6c2. 6c2 is 15. 6c3, that was 20. 6c4 is the same as 6c2, which is 15. 6c5 is the same as 6c1, which is 6. And 6c6 is 1. So that's how you jump straight to a row without doing all the other rows. So we're going to try that. So this is a good method when the exponent is big and you don't want to do every single row from row 0 up until whatever exponent you have. Alright, so we're pretending we don't know that row 6 is 1, 6, 15, 20, 15, 6, 1. Okay, so for number 7, we're going to do 6, C0. So whatever the exponent is, it always starts with that on the left of the C, and then a 0 on the right of the C. Okay, then we take x. X has replaced a. X is just what's in the first spot. X to the 6th, y to the 0. This stays 6, 6c1, x to the 5th, y to the 1st. Alright, notice that the number after the c, so now we go 6c2, the number after the c is the same as the exponent on the second letter. So we had 6c2, and then y's exponent was 2. When we did 6c1, y's exponent was 1. Six C3, x to the 3rd, y to the 3rd. Plus, alright, we left off on 6c3, so now we're at 6c4, x squared, y to the 4th, plus now we're at 6c5, x to the 1st, y to the 5th, and one more, 6c6, and x to the 0, y to the 6. Okay, so now I have to simplify this. Try to squeeze this in. 6c0 is 1. 1 times x to the 6th times 1 is x to the 6th. 6c1. Alright, so we took care of this one. 6c1 is 6. times x to the 5th times y. Did that one. Plus 6c2. 6c2 is 15. X to the 4th y squared. Plus, alright, so we did this one. 6c3 is 20. X to the 3rd y cubed. Plus, we did this one. Now we're on 6c4, which is 15. That's a 2, x squared, y to the 4th, plus, so did that one, 6, x, y to the 5th, and one more. 6c6 is 1, 1 times y to the 6th. Here's our answer. Oops. Alright, and we saved the hardest problem for last. Alright, so what's difficult about this problem is there's a 2 in front of the letter. There's a 2 times d, and there's also a 1/2. So we've only dealt with like 1a plus 1b before. Alright, it's also subtraction, so that'll make it even a little more difficult. Okay, so we're going to use the same coefficients, but let's pretend we don't know. So the exponent is 6 again. So we're going to use 6c for everything. If the exponent was 7, then everything would be 7c. Alright, so everything's going to be 6c. So if we start with 6c, and you only start with 0, 6c0 times, now we're going to take 2d, and we want 6 of those, and we want negative 1/2, but we want 0 of those. Plus, alright, so we did 6c0, now we're going to go up to 6c1. The amount of 2d's is going to go down by 1. The amount of negative 1/2 is going to go up by 1. Plus, I'm going to try to fit one more term on this line. 6c2. The 2d's are going to go down by 1. And the amount of negative 1/2 is going to go up by 1. So now we have 2 of those. That's a 2 up here. Okay, so the exponent up here is a 2. Okay, next we did 6c2, so now we're at 6c3. The number of 2d's going down, so now we have 3 of those, and we have 3 of those. Remember, the total exponent always has to be the exponent in the problem, so it is 6. Next is 6c4, 2d. We want 2 of those, negative 1/2, 4 of those. Plus, counting up, we're at 6c5. 2d goes down, so now we have 1 of those, negative 1/2, 5 of those, and we have one more term, 6c6, 2d to the 0, and negative 1/2 to the 6th power. Alright, so now we have to simplify all that. Okay, 6c0 is 1. So we have 1 times 2d to the 6th. Alright, how do we do 2d to the 6th? 2 to the 6th is 64. D to the 6th. Okay. So one thing you should know is when there's subtraction in the problem, then it's going to alternate. So 64d to the 6th is positive, so the next one's going to be negative. Alright, so what is 6c1? This is 6. Yeah, let me cross this out because we already did that. That is 6. 2 to the 5th is 32. And then we have to multiply that by 1/2. So 6 times 32 times 1/2. 32 times 1/2 is 16. 16 times 6 is 96. We have minus 96 d to the 5th. And there is no other letter, so we won't have a second variable that's going up by 1. Okay, next term has to be positive. Let me cross this out because I already did that. 6c2 is 15. 2 to the 4th. Alright, so I'm going to write this here. 6c2 is 15. 2 to the 4th is 16. But then we also want this 1/2 squared, which is 1/4. So if you multiply those three numbers together, you get 60. 60, and we know it's going to be d to the 4th. So we're done with this one, and we know the next one is going to be subtraction. Alright, 6c3 is 20. So this is 20. 2 to the 3rd is 8. 1/2 to the 3rd is 1/8. I'm ignoring the negative because we're just going to use the alternating strategy to figure out whether it's positive or negative. So 20 times 8 times 1/8 makes 20. So minus 20 d to the 3rd. Alright, so this one's done. 6c4 is 15. 2d to the 2nd is 4d squared. And 1/2 to the 4th is 1/16. Alright, so we're going to end up with a fraction here. 15 times 4 times 1/16 is going to be 15/4. D squared. So now we're done with this one. Okay, 6c5 is 6. 2d to the 1st is just 2d. 1/2 to the 5th power is 1/32. Let me separate this. Okay, so we're going to end up with 12/32, which we can reduce to, if we divide by 4 on top and on the bottom, 3/8. We know this one's going to be subtraction. Minus 3/8 times d. This one's done. And notice the last term doesn't have any variables because d is raised to the 0 power. So we're going to end up with 1 times 1 times negative 1/2 to the 6th. So that's going to be 1/64. Alright, so this problem is now complete.